Hello, welcome to another video on the AQA skeleton code for 2026. This one is Ant simulation, of course. We're doing it in C#. I just thought before proceeding, worth mentioning that I have done some previous videos on this code. Do have a look at the first one first if you aren't familiar with the code. That will talk you through it. The code is a bit more daunting than it actually is. It's not too bad once you get into it, and certainly a couple of days you can find your way around it if you're fairly familiar with C#. So just regarding the changes that we're doing today, the ants die off when there isn't food. In fact, let's just go to that point in the code now. So Control and F. We'll go to the class nest, which is where all that happens. So here we've got class nest. We have the food level and the number of queens as a protected integer. That means they're available within this class and anything that inherits from it, of course. And we've got the start food level, which is passed over to the nest. We have number of queens and such like. So here you've got the change food level. That's called up within the advanced stage, which alters the food level, and if it goes too low, it just sets it to 0, so you can't have a negative food level there. Then we have this getter here, which returns the food level to other parts of the code. So this is the advanced stage here, and we set the ants to cull equal to 0 to start off with, and the ants in nest is also set to 0. And then here we do some calculations. So we go through the ants using this for loop. So the ants is a list, of course. It goes through it. If the ant lives on the same row and column that we're working to here, so if those match, we then do some adding up. So if it's a queen, we're increasing this count here. Now that count is the food level, the amount of food that the ants consume for every advanced stage, every stage or every tick, if you like. And workers consume less. They only consume 2 bits of food. Queens consume 10. You'll also see here that we've got the ants in nest count. Now that isn't added to for the queen. It's only added to for the workers or soldiers if you've added them like I have. So that only gets totted up for the non-queen ants. Then we, once we've done that for loop, we change the food. So we're basically subtracting that count from the food level. Okay, here. All right. So let's get back to that part again. We then work out how many ants are going to not survive. So if the food level is 0, so if it's actually gone back down to 0, and there's more ants, that there are ants in the nest, then the ants, we're adding 1 to this ants to cull. We're not removing them, if you note here, directly from the list at this point, because that could cause errors if we're modifying a list as we're sort of trawling through it. So we're just adding 1 to the ants to cull here. You'll also note that that ants in nest, as I just described earlier, like about 30 seconds earlier, is actually only totaling up the non-queen ants. So I think that might be a bug, and I'll tell you why in a minute. I think it should be all the ants in the nest that we need to be working on there. Somebody from AQA who wrote this code might argue differently, I don't know. So we're then checking this second if statement here, if the food level is less than the ants in nest count. And then we're adding another one to the ants to cull. Then we've got this further one here, that if the food level is less than the ants in nest times 5, then we start, we add, one to the ants to cull, and then we, if the ants to cull is greater than the ants in nest count, then we set the ants to cull equal to the ants in nest count, so that we're only culling as many ants as there are in the nest. But again, that's not going to include the queen in that count, okay? So we then come to this bit here, where we go from 1 to ants to cull. So we've totaled up the ants that we need to cull off, and then we go through the through the list of ants here. We randomly select positions within that list, and then we double check to see if the ant is based at that nest by checking the get nest column. That, of course, if you'll know that ants are stored in grid on a linear single dimension list, so it has to work out the nest row and the nest column. So it's not stored on a two-dimensional array. See previous videos if you're not sure about that. And then if it is, we then drop out of there. We check to see if the type of ant is a queen, and if it is, then we need to reduce the number of queens, and then we remove using the ant, this is a standard list operation, isn't it? Remove at, and then our position, it's going to be removing the ant from the list. So I thought that the workers would give up the food for the queen, and the queen would be the last one to die in the nest. And I confidently made a video yesterday that just simply made some changes to check this ants in nest, because I thought that was the number of ants in the nest, was greater than 0. And if it was, then we would not select a queen within this loop here. So I put this extra condition in this loop to check to see if it was a queen, and if the ants in nest was greater than 0. I hope you're following this, so it'll come clear in a minute. If the ants in nest was greater than 0, then we would just go back and select another ant to cull off, and not a queen. And then if it was set to 0, then there are no more normal ants left, the workers and soldiers and such like, and then the queen gets it then, okay? It drops out and then comes through, and then we remove the queen. It didn't work. The reason it didn't work is that if you've still got a queen, you're down to a queen, and you've got an ants in nest is equal to 0, okay? So you've only got a queen, you've got no soldiers or workers or anything else. Then what's going to happen here? 0 times 5 is equal to 0. Food level might be equal to 0, okay? But 0 is not less than 0, so this code would never execute. So the queen effectively became immortal. So what I'm going to do now is I'm going to cut and paste the code changes that I made, because it was a little bit fiddly. It was harder than I first thought, and then I'll explain to you what I did. Okay, so I've cut and pasted the code in, and these are the changes that I've made. So we're still within the advanced stage. So first of all, I've decided to count the queens in the nest as well as the ants in the nest. So this is the where we're going through the list. I've declared the queens in the nest here as well as the ants in the nest. So that and that line there are new. So I'm adding up the queens in the nest. Then what I'm doing is I'm going to, we reduce the food level as normal. Then here, I'm getting the total ants in the nest. So again, that is a new integer where I've totaled up the ants in the nest plus the queens in the nest. So the ants in the nest are the non-queens and, you know, the workers and the soldiers. And then I've added the queens in the nest to it. So this is the bit where the program didn't work before. If the ants in the nest was 0, then it wouldn't. Sorry, it was down here. This bit, this if statement wasn't working. So, but I've basically changed the rules throughout. I've included the queen in the ants to cull calculation, which I think is right. So the total ants in nest includes the queen. We're using that in the calculation. And more importantly, here, this if statement will run when there is a queen, okay, which it wasn't doing before. So I've got the total ants in the nest times 5, totaling up the ants to cull, and then we are randomly going through the list as before, but you'll see I've added some extra code in. I've introduced here, and you can see it there, a boolean called don't cull the queen. Okay, so if this is set to true, then the queen doesn't get culled. And the reason it is we won't cull the queen is if it's not in the last round of cullings. Okay, so if the type of ant is queen and the total ants in the nest minus the ants to cull, so if you remember, that is the running total of the ants that we're going to cull further down. So we've been totting them up. If that is greater than or equal to 0, we are going to save the queen. Okay, so we're gonna save the queen, and I've just to prove the program's working, I've put this right line in here so I can see what's going on. I've put in a couple of other right lines as well to sort of show what's going on with the code. So here it will tell me the queen has been saved because there are still workers or soldiers left knocking around, and they will save the queen. Okay, I put in a read key there just because when I was testing it, I just wanted to be able to pause the program and go on. So if we're saving the queen, we set this don't cull the queen equal to true. Then, as normal, we're checking to see if it's part of the nest. So if it's not part of the nest, we go round and do that again. And or, those two pipes there mean or, we don't cull the queen, we're going to repeat that again and find another poor unsuspecting ant to kill off, and not the queen. So it just goes back and randomly picks another ant. Then, if we've dropped out and the type of ant is equal to queen, so, you know, this will only happen, of course, if we're on the last culling of ants. So that ants to cull might be 2 or 3, and the queen might be one of them, so, you know, it would drop down. And there we subtract 1 from the number of queens integer. And then I've just put a right line to say the type of ant that's been removed. So get type of ant is already there. That's part of the skeleton code. It returns the type of ant that it is, so that could be queen or worker or whatever it is. And I've just put removed. and then I've actually removed it. Of course, you can't put this the other way around. If you put the remove first and remove it from the list, you'll get an error there. So you have to put the right line before. So I'm telling a slightly white lie. It's not quite been removed yet, but it will be the next line of code. Okay, so that is it. So that will make sure that the ants that are culled are not the queen until actually there's no more ants left to cull. So I'm going to run that code now and just show you what's going on. Hopefully this will work. So I'm going to pick simulation 2. I'm going to advance it one stage. So if you've watched one of my previous videos, I've changed it into a 2-dimensional display here. It doesn't really matter. I've also introduced an anteater. Well, I've commented out the code where the anteater moves about, so it's not going around devouring ants from the nest, so I can just see what's going on. When I was testing it, it would go and jump to the nest and start, killing off the queen anyway, so I didn't want that to happen. And of course you can see that these are worker ants, that's a queen ant. Okay, so I'm going to advance one stage, and you can see a soldier ant has been spawned there. What I'm going to do is I'm going to go to 5 and advance a number of stages, and just because it's easy I'm going to do 5, 5, because that's where my finger is. So here you can see we've got the soldiers, and the soldiers dying in battle. That's code that I've introduced, of course, in a previous video. And then we've got the ants to cull. It's removed the soldier, removed the worker, removed a soldier. Another 3 ants to cull. It's saved the queen here, okay. So it's got 3 ants to cull, and it's removed 2 workers, and it saved a queen, but we've still got 4 other ants left. And if you remember, I put a read key in there, so I'm just going to press the return. It's actually found the queen again. Okay, this time it's found a worker to remove, and we've got back to the ants to cull again. Sorry, I should say, I don't think I showed you. I'll show you in a second. That ants to cull I put in as a right line just before the loop that culls the ants. We've got 1 queen left. We've just saved a queen, and there are 2 ants knocking about. So let's just press return again. It's removed a worker. The queen has been saved. Saved. Okay, so we've got stuck in a loop. So I paused the video. It was a very quick fix actually. That shouldn't be greater than or equal to 0, because of course if the total ants in the nest is 1 because it's a queen, and the ants to cull is 1, then that's going to be equal to 0, and of course it's a queen, so we're going to set this don't cull queen. So that is a bug. If I just change that and take that minus sign, sorry, that equals sign out, if there's 1 queen left in the nest, minus queens to cull. Okay, so we've already found that it's a type of ant queen. There's only 1 queen left, no other ants, and ants to cull is 1. That's going to be equal to 0. It won't execute that code, and it'll drop out of it. So that was quite a good little demonstration, unintentional, but we'll just test that program again now. So simulation 2, we'll move it on 1 stage. Oh yeah, the other thing is you'll have seen in a previous video that I've included the display straight after moving it on one stage or X number of stages, just to save continually typing one. So here we go. We'll run it again 55 times. Queen has been saved. There are 10 ants left in the nest. We've removed a worker. There's a queen's been saved again. Down to 3. Queen has been saved. And eventually ants to cull. The queen has been the last ant to be removed, and you can see there are no ants left on the board. So that concludes this. I'll do the other change in my next video. So we'll conclude that video there and see you in the next video.